Hello everyone, welcome to Skilled Dev. Trey here, and in this lesson, we're going to work the question, combine blockchains. And this question is presented as a story. It says that you found two separate blockchains, that combining them into a single unified blockchain will create a technology that could revolutionize the world. These blockchains are represented as linked lists, where each linked list has a timestamp property, which is a Unix integer timestamp, and they're sorted in ascending order in their separate blockchains. What you want to do is create a merged blockchain where all the nodes are sorted in ascending order combined. So here's our node, which is very similar to our standard linked list node, but instead of a data property, it has this timestamp, which we know is an integer that shows when the node was created. We have two separate linked lists. Each of them has nodes created at different times that are sorted by the order in which they were created. What we want to do is merge them together such that all the nodes combined will form a sorted, ordered linked list. So you can see the 42 comes from the first blockchain, the 123, the second item, comes from the second blockchain, 159 from the first, 482 from the second, and so on for ascending order for all nodes. So let's now visualize this a little better. Here we're just going to have the two linked lists. Each of them are going to have three nodes. You can see they're all integers in ascending order in each linked list. And now to make the comparison, we can really quickly see that all we need to do at any point is just to compare these two front nodes. So in this case, we say 2 is less than 4. So 2 is going to be the front node, the head node of our new linked list, the merged linked list. So we initialize the linked list, 2 is the head, and now it's also the tail to start, and we can see that it's pointing to null. Now we can also see that we iterated forward in this linked list after we used the 2. So then next time we're going to compare the 4 again, but now to this next item. We see that 10 is greater than 4, so now the item from the other linked list will become the second item in the merged linked list. So now we set the next value of the tail, which is also the head since it's the first node, to this 4. Now we combine them. So the head stays the same, we have a new tail, and the tail points to null. We can also see that we iterated forward in our second linked list. Now we just do this comparison again. We see that 10 is less than 42, so now this becomes the third item in the combined linked list. We set the tail's next value to equal to this node. We now have this reference, and now we move forward again. So let's kind of talk through what we've just done. We were maintaining a reference to the head in the combined linked list and the tail. The head is just going to be what we return from this function, so we need to maintain a reference to it the whole time. We maintain a reference or a pointer to the tail so that when we add these new items, we can always just append them to the end. We also saw that after we added an item to the combined linked list, we needed to move past it. So we have a pointer on each of our input linked lists that will iterate forward each time the item is used. So not only does this allow us to move past ones that have already been used, but now we can very easily just always compare these front items. It's always going to be that front pointer that we're comparing values of to get them in ascending order. So let's continue. We see that the final item in skilled chain, 11 is less than 42, so now we append this to our combined chain. And now we're out of comparisons, so what do? Well, skilled chain's empty, DevCoin has 2 more items, and we need to know, okay, well, how do we finish this? And the answer is, we know that both of these linked lists are already in ascending order, so there's no comparisons that need to be made. We know that everything beyond this front item is in the correct order after it. So all we have to do is just append this other linked list once one of these linked lists runs out of items. So let's reiterate that. Since there are no more comparisons, all you need to do is append this other linked list. So we do that now, and with that we have our fully combined linked list, all in ascending order, starting with 2, ending in 50, and we just did so by comparing those front items each time, And then finally, appending the rest of the items once one of our linked lists ran out. So to do this iteratively, we know that we need to use a while loop. That's standard for linked list. So how long do we use this while loop? Well, we don't know the length of either linked list, so we have to just continue until we run out of nodes. And we saw that when we added all the items from that other linked list, that was the end. So once one of these linked lists reaches null, we know that we're done. And this is the terminating condition for our algorithm. So let's just walk through what we did in that solution. We're always comparing these front items. And to compare the front items, we need a pointer to the current node. By having access to the tail pointer of the combined linked list, we can always just append items in constant time. So we move that one over, we iterate the tail pointer to that item that was just appended, and we move past it in the linked list that it came from. So we continue to add these items and move them forward each time. So we have 4 pointers in total. We have one to the head node, which is just what we return from our function. We have one to the tail node, which is how we continue to append. And then we just have one on each linked list, 2 in total, where we are always comparing the items. The big O time complexity of this is linear time, O of n. And we're calling n here all the nodes in both blockchains combined. We're not adding any new data structures, we only use 4 pointers, so the space is O of 1, it's constant space. And now we're ready to write our solution function, combine blockchains. This function takes the head of the first blockchain and the head of the second blockchain as its arguments. The first thing we're going to do is just initialize the head node for the result. And the head node for the result is just going to be the smallest head node of either of the 2 blockchains, which will be the first node in our merged linked list. So if the timestamp of the first head is less than the timestamp of the second head, then we return the first head. Otherwise, we return the second head. We also want to initialize the tail. And since we only start out with one item, the tail and the head are the same. Now we'll set the current node for each linked list. This is the one that's pointing to the current smallest item. And now we want to make sure we iterate past the item that was already appended to the result. So we'll do the check again. If the first timestamp is smaller than the second timestamp, then we iterate current node forward 1 spot for the first linked list. Otherwise, we know it must have been the second linked list. And now we're ready to begin iterating through both linked lists, and this is going to be in our while loop. And we said while the current node for the first linked list is not null, and the current node for the second linked list is not null. So we keep iterating as long as there are non-null items in both of our linked lists. And now we just make our comparison. We try to see which front node of either list is the smallest. Whichever one is the smallest, it needs to be added to the merged linked list because this will make it next in the ascending order. If current node 1, the first current node of the first list, if its timestamp is less than the current node, the front node of the second linked list, then we append the current node to the linked list. So we add it to the tail. And now we need to iterate that current node 1, the node from the front list, forward since we use that item. Otherwise, we just do the same with the other linked list, because that will mean its timestamp was the smaller one. We move it forward as well since we've used it. And now we've added the item that is next in our linked list, that next ascending item that should be merged. We've also iterated the item forward so we don't use it again. And now finally, we need to move our tail forward. So the tail is just going to be whatever item was just added. So we iterate it forward to the new tail, and this new tail will allow us to continue to append to the end. And that should do it. That should let us get through the entire linked list and add items until one of the lists runs out. And finally, we know that if one list runs out, well, then that must mean the other list has at least one node still in it. Since that node is already sorted correctly, we can just append all those nodes to the end of the combined linked list. So we'll say combine tail.next if current node 1 is equal to null. Well, then that means we put current node 2. Otherwise, then it must be current node 1. We stored a reference to our head node, and this head node, its next value goes to the second item, that item's next goes to the third, and so on until we reach the tail. So by returning the head, we return the full linked list of merged items in correct ascending order. Let's run our code, and it passed. So we've correctly merged our linked list in ascending order such that all the timestamps are ordered correctly. Thanks everyone, and I'll see you in the next lesson.